Now, if we're able to establish that two triangles are similar to each other, we can actually use the properties of similar triangles to find things that we don't know about them, specifically unknown side lengths with them. And that's because we know that with the properties of similar triangles, for them to be similar, they're an enlargement of each other. And because they're an enlargement of each other, they have to be equiangular, and the ratios of the corresponding sides have to be the same. So we've got two triangles here. We've got the triangle ABE and we've got the triangle ACD. Before we can calculate the value of x, we actually do have to ensure that these two triangles are similar to each other, because if they're not similar to each other, then we can't say that the corresponding side lengths are going to be the same, of the same ratio. So that's the first thing we actually have to do, is establish that these two triangles are similar to each other. So the first thing that I noticed with these two is they share a common angle at the vertex A. So we can say here that the angle at A for the triangle ABE, so between B and E, must be equal to the angle at A again, but for the larger triangle, it's going to be between C and D. Now, our reason for this, as it was in the previous video, is this one is common. They share that same vertices, they share that same angle. The next one that I'm going to look at is, you can look at actually at the vertices B and C, or you could look at E and D, because I've noticed I've got these parallel lines here again. So what I noticed with that is this angle here and this angle here correspond with each other, which means that they actually have to be equal to each other. So that'll be the angle at B between A and E is equal to the angle at C between A and D for the larger triangle. And as I just mentioned before, they are corresponding angles. And that's our reason for why they have to be equal to each other. Very important that we do establish the reasons each time. Now, as I said in the previous video, once we've proven that two of the angles in these two triangles are equal to each other, the third one has to be equal to each other, otherwise it won't add up to equal 180 degrees. So we can therefore establish at this point that triangle ABE must be similar to triangle ACD. And our reason here is angle, angle, angle. All right, so they're all equiangular. So from this point, now we've established that these two triangles are similar. What we know about these two triangles now is the ratio between the sides of them will be equal to each other. So when I like to look at these, you could look at the ratios of corresponding sides, which is what we tend to do. So the corresponding sides I'm looking at is, I'm looking for this side length here between B and E. So the corresponding side for the larger triangle will be between C and D. So if I go that length here, the length of BE, and divide it by the length of CD, the ratio of those sides should be equal to the ratio of this shorter side here, between A and B, and its corresponding side between A and C. So this will be the shorter side between A and B divided by the longer side between A and C. So what we can now do is we can substitute what we know. So between B and E, that's our value of x, that's what we're trying to find. The length of CD is 7. The length of AB is 6, and the length of AC, well, that'll be the 6 between A and B, the 4 between B and C, so that'll be a total of 10. Now, from here, we just need to, I'll think what this is called, use our inverse operations to be able to solve for x. So because I'm dividing by 7 here, if I multiply both sides by 7 to end up getting our x on its own. To find the x, it will be 7 times this 6 on 10. I'll just leave it as 6 on 10 just so I don't confuse people. Usually I simplify fractions when I can, so I was about to change it to 3/5. So if we do 7 times 3/5 essentially, we will find the side length here, which for our unknown value is going to be 4.2. And of course we can't forget our units. So our units here is centimeters. So when we're looking at finding side lengths of similar triangles, it's very important to note that before we start, we have to ensure that they are similar figures. Now, sometimes a question will tell you that they're similar figures. They'll say something like, given that the following two triangles are similar, calculate the value of x. If it says something like that, it means that you don't have to do that first step because it's told you that they're similar figures. If you don't know that they're similar figures, you actually first have to ensure that they are before you calculate the value of x, because otherwise you can't be certain that the ratios of the side lengths, like corresponding side lengths, are going to be equal to each other.